Hello, algebra students. I hope that everybody is doing well. We are moving forward out of Chapter 6 and into Chapter 7. We are in Section 7-1, and Chapter 7 is going to be all about exponents. So today we're beginning with zero exponents and negative exponents. And what I'd like for you to be able to do by the end of this lesson is to simplify things into their simplest form, particularly expressions that have exponents in them. So let's just begin with what an exponent is. An exponent is that little number that's written above and to the right of a larger base number, and it tells you how many times you multiply it by itself. So this is 2 to the 4th. That means 2 times itself 4 times. Or if we had 6 to the 5th, that would mean 6 to itself five times. So 1, 2, 3, 4, 5, 6 times itself 5 times. So an exponent tells you the number of factors of a given base in a power. So let's just write that out as kind of a pattern. And I do need to grab my calculator just a second. Okay, so we have these tables that we want to fill in, and let's write this out in an expanded form and what the number will equal. So we have 2 cubed, or 2 to the 3rd, which is 2 times 2 times 2, or 8. 2 times 2 times 2 is 8. 2 times 2 is 4. 2 to the 1st is just 2, so 2 equals 2. And notice what's happening here. I'm going 8 divided by 2, divided by 2, so we're going to keep doing that. So if I have 2 to the 0, that's actually equal to 1. 2 to the negative 1, if I divide by 2 again, then that's going to be 1/2. And 2 to the negative 2 is going to equal 1/4. So notice what happened here. I divided by 2 each time to get the next number. Or to go up, I multiplied by 2 each time to get the next number. Let's do that again. So I have 7 times 7 times 7, which is 343. And then 7 times 7, which is 49. 7 is 7. 7 to the 0 is 1. 7 to the negative 1 is 1 over 7. And then we have 1 over 49. So what this is actually doing is telling us how many times to multiply it by itself. But if it's a negative number, it's basically telling us how many times to divide it by itself. So let's do that again here. So I have x times x times x, which is x cubed. X squared is x times x. X to the 1st is x. X to the 0 is 1. So now if I'm dividing by x, to get into the negatives, this is going to be 1 divided by x. And this one's going to be 1 divided by x times x. So we are getting a pattern kind of in this. And what I would like for you to notice is first, look at what the value was for every single time the exponent was 0. The value was 1. So 0 exponents, I'm going to say a to the 0 is equal to 1 unless a equals 0. So any number risen to the 0 power is 1. Negative exponents are basically division of that expression. So negative exponents are kind of like telling you how many times to divide by that number. Okay, so let's just do a couple of examples so you can see this in action. Simplifying expressions. Oh, I'll also say this. Negative exponents, to turn them positive, I almost forgot. Put them on the opposite side of the fraction. And you'll see what I mean by that here in just a moment, but I am still going to block that in to turn them positive, put them on the opposite side of the fraction. That's pretty important. So let's begin. I have 4 to the 0. Well, any number risen to the 0 power is going to be 1. So this is just 1. 7 to the negative 3. To make that have a positive exponent, I want to make this exponent be on the opposite side of the fraction. So if I put this over 1, there's my fraction. And I'm going to say 1 over 7/3. So now when I flip the side of the fraction that this exponent is on, it has now become positive. Well, what is 1 over 7 to the third? Well, that's 1 over 7 times 7 times 7, or 1 over 343. The next one I have negative 5.14 to the 0. Well, anything risen to the 0 power, even if it's negative, even if it's a decimal, is going to still equal 1. Here I have negative 5 to the negative 2. So to make the exponent positive, not the base, but the exponent, I need to put it on the opposite side of the fraction. So if I kind of flip this around, then this is going to equal 1 over 5 squared. Whoops, negative 5 squared, my apologies. So now that becomes 1 over negative 5 times negative 5, or 1 over positive 25, because a negative times a negative is a positive. Let's simplify a couple more expressions. For number 5, I have 6 to the negative 1. My bad, that's not in the screen. Okay, so I have 6 to the negative 1. So I'm going to take this 6 to the negative 1, and I want that negative exponent to be on the correct side of the fraction. So this is going to be 1 over 6 to the first. Well, 6 to the first is just 6. So I actually have 1/6 for that answer. In this next example, I have some exponents that are already on the right side of the fraction and some that are on the wrong side. Notice how I have b to the negative 2, but a to the third is positive. Because a to the third is already positive, I'm going to keep it at the top, but I'm only going to move b to the negative 2 to the bottom. So this is going to become negative 5a to the third over b squared. And that's all I can do here because I'm not able to simplify it anymore. Looking at this one, I have x to the negative 5. Notice how this is on the bottom of the fraction and it has a negative exponent. To make it become a positive exponent, I just put it on the other side of the fraction. So this is going to be x to the 5th. I don't have to put the 1 there, but if putting the 1 there helps, then absolutely, by all means. Continuing on in example or number 8, b has a positive exponent while c has a negative exponent. I don't want negative exponents in my final answer. So I'm going to take the c to the negative 3 and put it on the bottom while keeping the 4 into the b at the top. So it's going to be 4b over c cubed. Moving right along with example 9, m to the second is fine where it is because it has a positive exponent. But n to the negative 3 is not looking so good. So I need to move that to the bottom of the fraction. But what's left over at the top? Well, there's still a 1 up there because remember, there's always an invisible 1 in front of my terms. So I'm going to have 1 over n cubed m squared. In example 10, the negative 2 is fine because the negative 2 is just a number. It's not an exponent. The a to the negative 3 we do need to put on the opposite side, so we're going to bring that to the top of the fraction. This becomes negative 2 times a cubed. All right, 11 is getting a little complicated, but that's okay. Just look at each individual piece and determine which ones you do or don't need to move. So the a has a positive exponent. It's fine where it is. The b has a negative exponent. I'm going to need to move that to the bottom of the fraction. The c has a negative exponent, so it needs to go to the bottom too. E to the 0 in the bottom is actually 1, so I can just cross that out and not worry about it. While f to the negative 3 in the bottom needs to be moved to the top to make that positive. So this is going to become a f cubed over d to the 6th. And now I'm taking this b to the negative 2 and putting it on the bottom, making it b squared. And then I'm taking c to the negative 1 and putting it on the bottom, making it c to the 1st. Because these are all letters and I'm not able to combine them anymore, then that's as simple as it will be. Finally, I have 12 to the 0, t to the negative 7, u to the negative 11. I don't want the negative exponents, and 12 to the 0 is just 1. So these are going to be moved to the bottom of the fraction, and this is going to become 1 over t to the 7th, u to the 11th. And there you have it. When you have a 0 exponent, it becomes 1, or the expression becomes 1. When you have a negative exponent, put it on the opposite side of the fraction. We can also evaluate these expressions, though, and evaluate means plug in and solve. That's all that means. So it says, what is the value of 3s squared, t to the negative 3, for t equals negative 3 and s equals 4? What we want to do first is take this expression and write it in the best way possible. T to the negative 3 is not very good. So this is going to actually become 3s squared over t cubed. Now I can take my values for t and s and substitute them in. So this is 3 times 4 squared over negative 3 cubed. Okay, so 3 times 4 squared, that means 3 times 4 times 4, because the 4 squared is 4 times 4. So that's going to get me 3 times 16. I'm doing my exponents, and negative 3 cubed is going to be negative 27. When I multiply the top part out, I end up getting 48 over negative 27. But both of these can be reduced by a factor of 3, so my final answer is actually going to be 16 over negative 9. Let's do that same thing in these next examples. So it says, what is the value of each expression for n is equal to negative 2 and w is equal to 5? Okay, so in this first one, we have w to the 0. Well, it doesn't matter what w is, because since it's risen to the 0, that's going to become 1, so I'm not going to worry about it. Then I have n to the negative 4. Well, to write this with a positive exponent, I need to take that and put it in the bottom of my fraction. So this becomes 1 over n to the 4th. Now I'm ready to substitute what my n value is, which is negative 2. So I'm going to have 1 over negative 2 to the 4th, which means negative 2 times negative 2 times negative 2 times negative 2. That becomes 1 over 16. But what if these got substituted into a different expression? Well, now this n has a negative 1 on it. I don't want a negative 1 exponent, so it needs to go to the bottom of the fraction. This is now 1 over n w squared. If you want to write the positive 1 exponent, that's fine, but you don't have to. So I'm going to plug in negative 2 for n and 5n for w. So this becomes 1 over negative 2 times 5 squared. Well, if I do that, then I have 5 times 5, which is 25. 25 times negative 2 is negative 50. So I have 1 over negative 50. Finally, I have 1 over n times w to the negative 1. W to the negative 1, I don't like the negative exponent, so let's bring it to the top. This becomes w to the first over n. W to the first is 5. N is negative 2, and I can't reduce that, so I'm leaving it as a top-heavy fraction. Now, this can also be used in real life situations, in particular with population growth. So here it says a population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1,000 multiplied by 2 times h, where h is the number of hours after a scientist measures the population size. Evaluate the expression for h equals 0 and h equals -3. What does each value of the expression represent in the situation? So all we have to do is take this expression and substitute in our values. So let's do that. I have 1,000 times 2 to the 0. Well, 2 to the 0 is just 1, so I have 1,000 times 1, which is 1,000. Well, what does this mean? 1,000 what? So this means the population is 1,000 at 0 hours. Now let's plug in the -3 and see what would happen to the population then. So I have 1,000 times 2 to the -3, which is equal to, I want to move this to the bottom of the fraction just to make it be a positive number. So I have 1,000 over 2 cubed, which is 1,000, sorry, 1,000 divided by 2 cubed. Let's see here. That equals 125. So this is equal to, I shouldn't have written it like that. This is equal to 125 because this is 1,000 divided by 8. So this is the population. For lack of a better way to put it, 3 hours ago. Because the h is -3 and h represents hours and time, so that means it was in the past that this is what this was since that's a -3. So the population was 125 3 hours ago. All right, if you have questions, make sure to bring them to me in class, and please have a great evening.